Good morning all. It's my honor to introduce today's second session resource person, Dr. K. Lakshminarayanan sir. Our resource person, Dr. K. Lakshminarayanan, has completed his BE from Dr. Sivandiadityanar College of Engineering, Trichandur in the year 2007. And he joined as an operations and maintenance engineer in Ericsson India Private Limited from the year 2007 to 2009. Later, he has completed his MTech in VLSI Design and Embedded Systems in Dr. MGR Educational and Research Institute, University, Chennai in the year 2012, and PhD in VLSI-based image processing from St. Peter's University, Chennai in the year 2019. He is presently working as an associate professor in the Department of Electronics and Communication Engineering at Francis Xavier Engineering College, Tirunelveli. He has 8 years of teaching experience and 2 years of industrial experience. He has developed many innovative products, and also he has filed 2 patents in embedded systems and IoT area. He is a member of various professional bodies and organized various funded workshops and STTPs. He has wide publications in the highly impact journals in the area of Internet of Things and image processing. He is currently leading the Internet of Things Applied Lab of Francis Xavier Engineering College for the past 2 years. Now he is going to handle the session, Recent Trends in Data Science for IoT Connected Devices. We welcome you, sir.
Yeah, thank you, Tina ma'am, for your kind brief introduction about me. So I'm starting my session and I'm presenting my screen. Is my screen visible?
Yes, sir. It's visible, sir.
I'm audible, right? Am I audible to all of you?
Sir, audible, sir. Noise is coming, sir. Why I don't know.
It's clear, sir.
Okay, sir.
Participants, am I clear? Is my voice clear?
Yes, sir. Voice clear.
Yes, sir.
So good morning to all the participants who have joined from various institutions and industries for this ATAL 5 days online FDP, Faculty Development Program on Data Science. And I'm Dr. Lakshminarayanan. I'm an Associate Professor of Francis Xavier Engineering College. And so today's session will be a hands-on session, a completely a device-based hands-on session, because Internet of Things and data science are much related. So if you are learning about data science, we need to know about Internet of Things and how to generate data through Internet of Things. So this session will be a complete hands-on session, and I'll just quick rush up with theory part in a few minutes, and then we'll directly jump into the hands-on session. So first of all, I would like to thank Dr. R. Ravi, Professor, Department of CSE, the organizer or the coordinator of this 5 days STTP, for giving me this opportunity to present a session in this August gathering. So thank you, Ravi sir. And,
Thank you, Professor.
so this will be my session outline. The things which are theoretical will be very simple. Let us make it very simple. Like it starts with what is Internet of Things, and later on we'll be looking on various applications which are there involving data science as well as Internet of Things, and how data science is collaborating with Internet of Things for generating data. So those things we'll be seeing very briefly, theory, and then we'll be jumping into the hands-on session, and we'll start with a simulation tool for an embedded system. This we call it as Tinkercad, and if you take Internet of Things, the very basic thing you need to know about is the embedded systems. So embedded systems is nothing but it is a combination of software and hardware. So this is what is the definition we can see everywhere for embedded systems. So it is nothing but it is a combination of hardware and software. Hardware is nothing but your integrated circuits or controller, and software is the program whichever you write over that hardware. So it is a combination of software and hardware. So when we incorporate the internet over this over the top of embedded system, it becomes IoT, Internet of Things. So we'll be seeing the basics of embedded system that we'll be seeing through a simulation tool which was given by Autodesk. I think most of you would have know about Autodesk, who is the manufacturer of or the creator of this civil-based AutoCAD softwares, right? Civil and mechanical-based AutoCAD softwares. Secondly, we'll be seeing about a very user-friendly cloud server, that is Remote XY. This is also a very simple tool to learn IoT. So for a beginner, because most of you are new to this board-based Internet of Things, because it is quite complicated to switch on from a software-based domain to hardware-based domain. So it is quite tough to learn what is there inside the hardware. So this particular Remote XY cloud server will make it very easy for a beginner. Then we'll be seeing about a Blink server, and finally we'll be seeing about a ThinkSpeak server. ThinkSpeak server is nothing but which is much related to data analysis and data visualization. So what exactly we are going to do in ThinkSpeak is that we'll be connecting some sensors with the microcontroller, and we'll be reading that sensor values through a cloud, and we can able to analyze those data through this ThinkSpeak server, and this is also an online tool. So this is what is the session outline. So now let us quickly go through the theory part. So what is Internet of Things? Internet of Things is nothing but it describes about the network of connected objects or physically connected objects that are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging the data. So it is nothing but all sorts of connected device or any sorts of electronic device which is incorporated with sensors, softwares, and microcontrollers along with internet for exchanging the data between each other. That is what we call it as an Internet of Things. So I think this is a very common definition which is given for Internet of Things. It is nothing but a connection of a connected device or internet connected devices. So this is what we call it as Internet of Things. So now let us look into the growth of IoT. This was predicted in the year 2011. So as per that prediction, in the year 2020, the number of connected devices will be around 50 billion. So it is not a small value, it is a huge value. That is 50 billion connected devices will be there in the year 2020. It was predicted in the year 2011 itself. and it was predicted like around 7.6 billion will be the population of the world in the year 2020. But actually speaking, they have almost reached this prediction. But it is not exactly 50 billion right now, because due to this COVID situation, there was a slight lag in the number of connected devices. That is, it was predicted that it will be around 50 billion, but it is not 50 billion right now. It is around 39 to 38 billion right now. Actual data which was gathered in the internet. So it was around 38 or 39 billion right away in the year 2000. That is as per the September 2020. But if we consider the world population, it was predicted around 7.6 billion. But the actual case is that we have crossed 7.8 billion. So COVID does not disturb the world population, and as it has crossed 7.6 and now it has reached 7.8. So this is a funny fact in this particular slide. So this is about the growth of IoT, and we can see the number of connected devices are more than that of the world population. So if we consider about the smart systems and IoT, so what are the things which are incorporated to make a product a smarter product? So the things which are required are sensors and actuators. Second is connectivity. And the third one is the people and the process. So these are the three major things which makes a system smarter or a smarter IoT system. So if we consider about a sensor, we got n number of sensors for any kind of application which is there. So starting from in the field of agriculture, we have different varieties of sensors for the agriculture alone. We got sensors for monitoring the soil moisture. We have sensors for monitoring the level of minerals in the soil. And we have sensors for measuring the humidity of the soil. So likewise, we have n number of chemicals and minerals which are incorporated in the agricultural field. In order to monitor all those physical parameters, there are n number of sensors which are there available in the field of agriculture also. So if we take healthcare also, we have n number of sensors because recent days we can find many inventions such as body implants. Body implants in the sense those sensors will be fixed over the body, or it will be implanted inside the body, so that it will continuously measure the parameters, body parameters, and it will be broadcasting the data to the hospital or to the person who is connected to that sensor. So likewise, you got n number of sensors for different applications such as humidity, moisturing, then chemical and gas sensor to measure the flow of water inside a pipe, and to measure the load, that is how much weight it is going to it is carrying, so it can measure the leakages in the pipe, or it can there are sensors to find out the cracks which are there in the railway lines. And we have acceleration and tilt sensors. Acceleration and tilt sensors is nothing but whenever whichever there which we have in your mobile phones. So when we tilt our mobile phone, your display in your mobile phone automatically turns. That is because of the accelerometer which is there, or that is your gyroscope sensor which is there inside your mobile phone. So mission vision is also a type of sensor, because camera is also a sensor which is also able to connect some able to collect some data, and which can be analyzed, and it can be converted to a knowledgeable effect of smart products. So these are about sensors, and the major a requirement for a good sensor nowadays is like the first thing which we need to which is to be considered is reliability. So reliability is the major requirement, or yeah, it is the major requirement of a sensor, because if we consider a load cell is nothing but this particular load cell sensor is nothing but it measures the weight of a particular object. So we can find this load cell over different industries, okay, for measuring the weight. So if a particular object is of 100 kgs of weight, it should show 100 kgs. So it should not show around 70 kgs or 80 kgs or 90 kgs. If it is 100 kg, it should show 100 kg. So that is what we call it as reliability of a product. And the second thing is the possibility of reducing the size of the sensor. So this created a new field that we call it as a nanosensors, and so this field is also, it is getting emerging, or this can be called as nanosensor or MEMS sensors, micro electromechanical system, and these are the different fields which are developing in recent days, which are based on sensors. And the next major thing is about the amount of energy which is being consumed by the sensor. So these are the three different requirements for a sensor to be a good sensor, or a good sensor to be incorporated for a smarter product. So the next one is the connectivity. As I told, there are three different components that make a product smarter, or a smarter IoT product. The second thing in that is the connectivity. So the connectivity, as the many as per today's requirement, there are more and more number of real-time applications are involving Internet of Things. So initially, for communication purpose, we used infrared, and later on we went into Bluetooth and RF, that is radio frequency, and then we moved to GSM based communication. I'm just speaking about the embedded systems. So device to device communication was done through that. So you can even take the example of your mobile phone. So initially there was infrared in your mobile. Through that we communicated with each other. If we want to transfer some data from one mobile to another mobile, we used infrared. And later on we got developed into Bluetooth, and right now we are having Wi-Fi based data transfer, that we have many such applications like Share It, and many such applications are there. So we can take that example. While we consider about embedded system, initially we used infrared for communication, and later on we developed into Bluetooth and what we say, that is RF. So later on it got developed to internet, that is GSM based internet, and later on the 4G started developing, and based on the current requirement, that is the huge requirement of data transfer in a fast way. So this made developing your 5G technology. So this is what is about the connectivity. So as I can summarize that, as the complexity of the device and the requirement is getting huger and huger, and the data transfer is also the data transferring speed is also it is required to be high. So this made the development of 5G technology in brief. So this is about connectivity. And the third component in that smarter product is people and process, where exactly we are going to implement make use of the data which has been collected from the sensors, and what exactly we are going to do with that particular data. That is what we call it as people and process. So it can be used in a financial sector, it can be used in supply chain management, it can be used in security and energy purpose, it can be used in control and automation purpose. So this is about the places where we are using that. So what process you are going to perform using the data? So we can perform data analytics over there, or we can perform any artificial intelligence with the data which is there available with the through the sensors. So when all these three components, that are sensors, connectivity, and people and process, so when these three combine, it becomes a smarter system. So this is what I'm trying to tell. So these three components are very important, that is sensors and actuators, and then connectivity and people and process are the three major things which are which are playing a greater role in creating a smarter system or a smarter IoT product. So while considering about the IoT, we have a wide variety of applications, starting from home automation or home consumer, transport, health, business infrastructure, and smart city developments. So all those things are the applications of your Internet of Things, but it is not limited to these applications. We got wide variety. So based upon the human thinking, we can able to even improve the applications of your Internet of Things. So these are a few small applications which are there right now available, that is Internet of City for smart cities. So in this picture you can see where are there your IoT is being used for making a city a smarter city. So there are some sensors to monitor the air quality, which are that is the cars and vehicles will be emitting carbon dioxide, so that that air quality will be monitored, and based on the air quality the traffics can be controlled. And secondly, we can see the surveillance camera, so all those surveillance details will be transferred over IoT. Then we got traffic sensor, and this traffic sensor is right now available with all sorts of this call taxi applications like Ola and Uber. So this tells about where exactly the traffic is more and where exactly the traffic is less, and which is the best way to choose the right path to the destination. So all those things, it is coming under the smart city product. So next is smart energy, and then we can see smart parking system. So so these are the simple applications which are which can be incorporated in a smart city, and which are there in smart city implementations. So here we can see one of the smart city application, that is smart parking. So this also incorporates some embedded system along with the Internet of Things. So each and every parking lot will be allotted with the RFID tag. So each car will be coming and standing over the parking, so that your centralized gateway will get an alert that that particular parking is not free, and whichever places where the RFID is not pinging will be considered as empty spaces for parking. Okay, so this makes an effective smart parking system. So this can be incorporated over Internet of Things, and right now it is not implemented in India, but it has been implemented in other developed countries like US and London. This actually cannot be implemented in India because of the huge population and the number of vehicles which are there. And of course, in India, certain rules needs to be taken in a control so that to implement these smart parking systems and all. Next is IoT-based corporation waste management. Here we can see a truck is carrying the garbage, and we got some embedded system implemented with the Internet of Things, which is kept on the dustbin. So when the dustbin is filled and it intimates the server, and from the server the corporation people will be knowing about where exactly this dustbin is there located, and that dustbin will be also incorporated with the GPS system, GPS monitoring system, and through that GPS monitoring system the dustbin's location will be monitored, and from the corporation there will be an intimation given to a garbage truck to collect that particular garbage. So this is also one of the smart city implementation project, which is actually taking place in many countries. Next is agriculture for IoT for precision agriculture. So there are many sensors, as I told, there are many sensors available for monitoring the parameters which are there in the agricultural field, such as soil moisture, various minerals which are there in the soil, like sodium, potassium, and so those things will be monitored, and water level sensors will be there. Through that, if there are different partitions in that agricultural field, in which partition there is the water level is actually very low, so that can be monitored, and if it is required, like for that partition alone we can pass the water, so that is to be explained clearly in this particular diagram. So here we can see a lot of partitions in that agricultural field. So one with the dark brown color says that there is ample amount of water quantity in that particular field. One in the light brown color tells that there is very little amount of water over there. So this particular node, which is incorporated with a microcontroller and an IoT device along with a sensor, will send a notification to the gateway, so that the gateway will be responding or turning on that particular water pump, or it can be controlled over a remote place from the owner. So these things can be implemented in the field of agriculture for making it a smart irrigation system. So next is cattle tracking. This is also a part of agriculture. And here we can, in the recent days, we are seeing some ad that is Vodafone Idea combining together, and they are developing a new brand that is called as We. So one boy will be coming and telling that goat was getting missing, and that girl suddenly takes a phone, and she'll be doing some operations on the phone, and she'll be tracking that goat through a GPS module. So that is what is we call it as cattle tracking. So this is not only for cattle tracking. We can able to fix this kind of modules that is the combination of a microcontroller with a sensor and a GPS module to track even like humans. Like if you are sending your kid to a tuition, you can just put that whole device into the kid's bag, and we can even monitor where exactly the kid is standing, whether he is going to the tuition or school properly or coming back properly. So all those things can be monitored through this kind of device, which combines a microcontroller, a GPS module, and with some internet connectivity with that. So this is what we call it as tracking, and this is also can be implemented to make a particular product very smarter. So IoT in healthcare, as I told, there are many implants which are there available. First thing we can see here is you can monitor the glucose level in your body, and based upon the glucose level, the insulin pump will be pumping the insulin inside your body. So these are the recent developments which are there in the healthcare, and at the same time, there are many wearables available right now which can able to monitor how much you have spent while walking, or how many steps you have walked, and how many hours you've been in sleep for the last night, and how was the sleep exactly. So all those things can be monitored through this particular devices that is which are incorporated with your IoT. So all those details from the sensors are analyzed. So this is where the things are getting accumulated, that is data science and your IoT and your embedded system are getting accumulated in this single product. So that we can see in this particular diagram. So glucose monitoring sensor just monitors the glucose level in the body, and it sends the levels to the insulin pump, and insulin pump will be checking the glucose level, and then it will be injecting into the body. Required amount of insulin will be injected into your body. And in case of that wearable that tracks the pulse level and heartbeat level which is there measured, and it analyzes those data, and it can even tell how long we spent our time in sleeping, and was the sleep was very good, or it was a bit like disturbed sleep, or it is a deep sleep. So everything can be monitored or through the sensors and analyzed through the data science. So this is where we can see the IoT for healthcare. In retail also, we can see Internet of Things application in a wider way. So here, whenever you enter into a shop and you pick some product from a shelf, so there will be a sensor monitoring all those packages. If one product is removed from the shelf, so that will be intimated, and the number of products will be reduced as you have picked one. So these things can be incorporated in your Internet of Things, and if you have some kind of tags which is being used regularly in that supermarket, if you punch that tag, you'll be that market owner will be getting all those details about what you purchased in the last month, and what you are purchasing today, and what is the difference in the price levels. All those things is able to known to everyone. So this is what is the IoTs and the data science application in the retail industry. So these are the different IoT applications, that is top 10 applications. So as the industrial revolution, that is industry 4.0 came, the application of this IoT in the field of manufacturing and industrial is getting huger and huger. And then transport and mobility, definitely we can able to see more number of vehicles which has been incorporated with the GPS facility and an IoT facility in order to track the vehicles where exactly it has been located. As nowadays the vehicles cost is getting more and more increased, and the security for that vehicle is also needs to be considered. So the transportation and mobility in the field of vehicles is also getting increased. Energy, definitely EB is now trying to incorporate IoT for its measurement of EB values. Then retails, smart cities, healthcare, supply chain, agriculture, buildings. Yes, buildings also there, because there is a broad area where we can apply this IoT. Is structural health monitoring. Like if we have different bridges, we can incorporate or implement IoT based embedded systems over there, so that we can able to monitor how much amount of load it is carrying daily, and if there is any deflection in that bridge, it will be made it known to that particular concern authority. So all those things can be implemented using this structural health monitoring. Not only for that bridges alone, we can monitor the health of a particular building. So if there is any cracks available, it will be able to know about that. So even the reinforcement, that is the steel rods which we incorporate while constructing the building, we can even monitor that particular health of that rod. So these are the different applications where you can implement IoT as well as data science, that is analyze the data which is coming from your sensors. So these are the things. Okay, so I think I've taken quite a long of time for IoT. I thought of completing it very briefly, so I'll directly jump into hands-on session. Okay. So before entering into the hands-on session, I'll just time is 12, right? I think I'm going correctly. Okay, so before entering into the hands-on session, I just need to give you a small introduction about what are the different boards which you are going to use today. And the first thing is we call it as an Arduino UNO. So this Arduino UNO is a very basic development board. This for any beginner. This particular board is not only for developing major projects. This is also suitable for kids for developing toys and small applications. Even school students are doing projects with this Arduino UNO, but actually this is developing right now. So we are very much required to know about what is exactly an Arduino UNO. So this Arduino UNO is nothing but it consists of a microcontroller over there, and this microcontroller we call it as Atmega 328. So this IC we call it as Atmega 328, and it works with the power of 12 volt if you are going to give direct that is AC supply, and it altogether it will work in 12 volt DC. Okay, and here you will be having a USB connector here, and the things which are there in the right hand side. So all those things are, that is all these different pins, we call it as digital pins, and altogether we'll be having 14 digital pins over there in your Arduino UNO. Through this you can able to connect digital sensors over there in this 14 pins. So this is the your digital pins. Okay, and in the other side, that is in your left hand side, you can see A0, A1, A2, A3, A4 and A5. So all these pins we call it as your analog pins. Okay, so you got a very minimum amount of analog pins, and you got 14 digital pins. So other side of your analog pin is your power pins. So here you got VIN, and VIN is nothing but if you are going to give 12 volt power supply, you can take an output of 12 volt from this VIN pin. Secondly, you got two ground pins available, and one 5 volt pin is available. So this 5 volt pin is nothing but in order to power the sensor, because most of the sensors which are available in recent days are working in 5 volt. Okay, so there are a few sensors which work in 3.3 volt also. So there is a separate two different separate pins for those 5 volt sensors and as well as 3.3 volt sensors. The next is a reset pin, and the other two pins is not being used in any ways. So this is about Arduino. This is what is the basic thing which we need to know. Secondly, this is ESP8266. So this is a Wi-Fi module. This makes us to connect with the internet. That is when we combine this Arduino and this ESP8266, that particular module will become as a IoT module, because that has an internet connectivity, so that if there is an available internet over your vicinity, so that you can able to connect it. So when we connect these two devices, that is ESP8266 and your Arduino UNO, now your Arduino UNO will be able to transfer the data through Wi-Fi. So other than that, it cannot transfer any data from this standalone device. That is, your Arduino cannot transfer any data, because we don't have any communication protocols in this Arduino UNO. It can just able to process the data. That's it. So when we combine this ESP8266 along with this Arduino UNO, we can able to transfer the data over internet. Okay, or not only this ESP8266, we have a Bluetooth device or Bluetooth module also. If we able to connect that Bluetooth device with your Arduino UNO, we'll be able to transfer the data to the other Bluetooth devices which is connected with this Arduino UNO. So this is what is about Arduino UNO and ESP8266, and it has 8 pins, and all those 8 pins is not being utilized. The majorly what we'll be using is the pin number 1, that is your ground pin. Pin number 4, that is your receiver pin. Pin number 5, which is your transmitter pin, and the last one is your VCC. Rest of the pin will be kept idle because it is not being used. Because why it is not used is because this particular ESP8266 also will be consisting of a small microcontroller with a very minimum memory, but we cannot. It is very tough to access that particular microcontroller. So what we are going to do is we are just going to disable this particular microcontroller, and we are just going to connect it with the Arduino microcontroller. So that is what is the thing which you are going to do. So that is why we are not connecting anything with this 2, 3, 7 and 6 pin. So we are just going to connect the Arduino with your ESP through this pins, that is pin number 1, pin number 5, pin number 4 and pin number 8. So these two combine together to form a IoT controller. So this is what is the combination of those two, that is your Arduino as well as your ESP8266. This we call it as your node MCU, and this is actually a development board. This is a module, that is your ESP8266 is a module. So it is not a development board, but this particular module, that is your node MCU, is a development board which is incorporated with a microcontroller. We can able to access that microcontroller through this node MCU, and at the same time it will be having an onboard Wi-Fi module, so that we'll be able to process the data as well as transfer the data over the internet. So this comes in two different variants. One is your Lowland and the other one is your Amica. So both of them are from VMOS. VMOS is a brand which is similar to that of your Arduino, and this is very less common because Arduino was taking its marketing strategies to reach even small kids. But these two boards are not much reached, but it is as effective as that of your Arduino board. That is, we call it as VMOS. And that comes in two different variants, that is Lowland and the other one is Amica. So this is, we call it as a node MCU, and here also we have certain limited features, that is we have multiple digital sensors, but digital pins, but we'll be having only one single analog pin, so to which we can able to connect only one analog sensor. Okay, so that is why it is getting lagging, because if you are going to use this ESP8266 and your Arduino, you'll be able to have around 6 analog pins and 13 digital pins, but there will be a very limited number of digital pins, and your analog pin, there is only one analog pin over here in your node MCU. This makes this particular node MCU a little lag. So it is not a problem, because nowadays most of the sensors are digital sensor and very few sensors are analog sensor. So we don't want to worry about that. So node MC is also a good board to get started with or get started practicing for Internet of Things. So next board is we call it as Wemos D1 board. So this also belongs to the same manufacturer, that is Wemos. This will be looking very similar to that of Arduino to make the users very familiar with the board. They have developed this particular board very similar to that of your Arduino, but this also has a very limited number of digital pins as well as your analog pin. This is actually very similar to that of your Node MCU, which has very limited digital pins, only one analog pin. Here also, as it is from the same manufacturer, they are just providing a very limited amount of digital pins, that is around 8 to 10 digital pins and only one analog pin. Okay, so this may look just like Arduino, but it will not. So you can see here. So it is just looking like an Arduino, but it is not exactly an Arduino, or it is just an ESP8266 model with a small microcontroller over it, which has an internet connectivity. You can see this ESP8266, which is fixed on board in this development board, that is a D1 development board. So this is about this particular board. And we got Raspberry Pi. This is quite costly. So if you are considering some simple applications, if you are going to just monitor the temperature, or if you are going to monitor the humidity, or you are going to monitor a simple soil moisture, this Raspberry Pi is not required actually. Actually, Raspberry Pi gives accurate results, or accurate processed results, but it is not much required, because whatever this Raspberry Pi is going to do can be done through your normal Arduino itself. Based on the requirement, you have to use the different modules or different boards. So this Raspberry Pi can be implemented where, like, if you are going to incorporate some kind of AI applications, artificial intelligence applications, or if you are going to process some data. So in those time, if you are going to do some analytics, or if you are going to use some applications which are related to camera, so all those things, for all those things, this particular Raspberry Pi is actually suitable for those applications. But for simple applications, we can just go for these boards. So that is your Arduino UNO, then Node MCU, then Wemos D1. So all those things are more than sufficient for us. So this is about the different boards which can be used for a beginner to implement embedded systems as well as your Node MCU. Sorry, your Internet of Things. So now let us jump into the embedded simulation tool that will just go for a hands-on session. So the first hands-on session will be on Tinkercad. So Tinkercad is a simulation tool for an embedded system. So we can develop simple projects or simple products. Just a second. Simple circuits using this Tinkercad application or Tinkercad tool. So participants, am I audible to you? Is it okay?
Okay, sir.
Yeah, thank you very much. So now let us jump into hands-on session. Ravi sir, I just need a clarification whether I need to give a demo, or participants will be reflecting what I'm doing in my screen.
Yes, sir. Yes, sir. Okay, sir. I am seeing your screen. Okay.
Participants, you are going to have a demo, whatever I do, or it should be like a hands-on session. Whatever your choice, I can do that. If you are going to reflect whatever I am going to do, it'll take some time, but I think I can give some kind of hands-on session to you. If you want like a demo, I can even do like that. So whichever you prefer, I can do. Can you please text me in the chat box so that I can adopt accordingly? Demo. I can see a lot. Demo. Okay, right. So then I'll show you a demo. That's much better, and we can make utilize the time, right? So So as I told, the first thing is I need to start with the Tinkercad. So I'm just opening Tinkercad. So this is the website for your Tinkercad, and this Tinkercad is actually for the beginners. So there will be many contests which will be posted in this Tinkercad for designing innovative projects or products, and you can utilize this particular online website to make your students participate in these contests which are there offered by this Autodesk people through this Tinkercad platform. So first thing what we have to do is we have to just give a sign in, or you can go with join now. Either you need to create your own personal account, or you can join with your email ID. I'm just going to do it with my email ID. There is no security issues with my email ID, so I'm just logging in with my Google account. So I can I'm having multiple accounts, so I'm just choosing one. So this is very simple to just open your Tinkercad online tool. So here you will be having multiple blocks, multiple modules there. The 3D design, and this is not for us, and this is for civil engineering people or those who are have good knowledge in designing 3D modules. We can go for that 3D designing, and what we require is the circuits. You have to choose this particular module, that is your circuit module, and what we have to do is you have to click on this create new circuit. We'll be having a tab called create new circuit. So this is the environment of your Tinkercad, and here this is your workplace. So this particular area, I think you can see my pointer, isn't it? Is my pointer visible to you? Mouse pointer?
Yes, sir. Yes, sir.
Okay, thank you. So this particular area, we call it as your workspace, and on the right hand side you can see few components. So this is your component selection area. Okay, so you can daily, on a not in a daily basis, in a weekly basis, they'll be introducing new components in this Autodesk. That is the excellent feature of this particular online application. That is what we call it as a Tinkercad. So the working in this Tinkercad online tool is also very simple. So you can just click on that particular component which you require, and you can just drag it into this workspace. That is the effort you are going to give to choose a particular product or particular component. So here what you are going to do is you are just I make utilized of a battery, that is a 9-volt battery. And now what I'm going to do is I'm just going to glow an LED with this battery. Okay, so I'm just clicking on that particular LED and just moving into that workspace. Now it is possible to change the color of this LED also. I can just click on this particular LED, so that I'll be getting this tab, so that I can able to change the color, either red color, yellow, orange, blue, red, or white, anything it might be. So white is not a color. You can give, let us take it as green, or let us even consider it as red, because it will be quite visible to all of you. What I'm going to do is, if you point out that particular legs over that LED, it will be denoting with a cathode and anode. Your cathode is nothing but your negative terminal, and your anode is nothing but your positive terminal. What I'm going to do is I'm just going to click on that particular terminal. If I just move your mouse, you can drag a wire. Okay, so this anode, I'm just going to connect it to the positive terminal of your 9-volt battery. And this cathode, I'm just going to drag it. Just have a click, and you can drag a wire. you don't want to put any other effort, just click and just move your mouse, a wire will be drawn. Okay, so that is the effort we are going to do. So now I'm just going to make this wire to be differentiable. So I'm just clicking on the wire. I'm just going to change the color of that particular wire. I'm just going to represent this negative as with a green, sorry, with a black, and I'm just going to represent this positive with a red color. So this is what this is a simple circuit. So whenever we start anything with an electronic component, all of a sudden we'll be looking into where is the battery and where is the LED. I'll just connect it together, it will glow. So this is what everybody will be thinking. Even in our childhood, we would have tested this. We'll be taking a battery, we'll be connecting a LED, and that LED will be glowing for some time, and it will gone lost, and it will never glow for the next time. So that is what you are going to see. This is a simple circuit, right? I'm just connecting a LED with a 9-volt battery. I'm just giving a start simulation. I'm just starting the simulation, but what happened? Your LED got bursted. Why it is bursted? It requires only 20 milliamps, but what is exactly coming is 915 milliamps. So what I'm going to do is I'm just going to stop it. I'm just going to put a resistor in between your positive terminal of your battery and your anode. So I can just select this particular wire, and I can delete. I can press the delete button to delete that particular wire. And what I'm going to do is I'm just going to introduce a resistor in between. So if I introduce a resistor, I can even change the value of the resistance also. So let me put like around 350 ohm. I think it is much enough for this particular LED. So I'm just again dragging a wire and then connecting it to the positive terminal of the battery. Now I'm trying to simulate it, and now you can see that the LED is glowing very clearly, and you can even test it with a low value of resistance. So here you can see, like I'll put around 200 ohm. 200 ohm. Just click on this particular LED and you can vary the value of your resistance. So here I'm just starting the simulation, but here you can see a warning there. What warning is nothing but this LED will right now at present it will glow, but it cannot be withstand for a long life. Okay, it will not be performing glowing for a long life. So that is what is being represented with this alert symbol. So that what we can do is we can able to increase that particular resistance value to 350. So now it is not giving any alert message. So this is what is the effort you are going to put for developing a simple circuit. So I think this is clear, right? How to select a component from your component bar, and then how to place it on the workspace, and how to start the simulation and how to stop the simulation. So this is what is the simple effort you are going to put to show what is the effort taken to just incorporate a component in the workspace. This is a simple example how we are going to choose a component. Okay, so now let us go into the main picture. Let us incorporate Arduino. Okay, so the thing is I can find Arduino UNO. Okay, this microbit is also another display device which is added today. I got a message that this particular component is being added today. So I'm making utilized this Arduino. That is, I'm just clicking this Arduino and just bringing it to the workspace. Right, you just don't want to change any parameters for this Arduino. If you click here, you can rename this, or otherwise you can keep it as it is. Now what I'm going to do is I'm just going to make use of a LED here. Okay, so in the previous example what we saw, is we just connected a LED with a LED with a battery. When we start simulation, the LED was continuously glowing. So if we need to incorporate some kind of a logic to glow this LED, that is, it has to kept on for a certain duration and it has to kept off for a certain duration, we can able to do that with an Arduino. So as I told, you can see that clearly in this particular picture, that is you are having 14 digital pins here starting from 0 to 13, and then you have 6 analog pins, and you have power pins. You have one 5 volt, one 3.3 volt, 2 grounds, one VIN, and through this VIN pin you can able to take 12 volt output if you are going to give 12 volt to DC. If you are going to connect your USB module with this USB connector, then you can't get a 12 volt. You'll be able to get only 5 volts. So whatever the input you give, you'll be getting through this VIN. So this is about your Arduino. So what I'm going to do is, you have, as I told you, will be having 2 legs in your LED. One is your cathode and the other one is your anode. I'm just going to connect the cathode with the ground which is there. If you need to connect it properly, you can just make 2 different clicks and you can move it. So there will be some geometrics available there, and you can make use of that geometrics, and so that you can draw a straight line or a curved line, anything. So if you need to just move this wire to some other direction, you can just click on this, double click on this particular wire, and you can just move like this. So if it is not required, you can go for undo, control Z, that will do undo. Okay. So I'm just going to connect this anode pin to some digital pin. Okay. So whenever there is a logic available, this LED will be glowing. If it is not, it will be turned off. So that is what it is going to do. It is going to perform. So these are output. We are just going to outputting that 5 volt to your LED. So before that, we can incorporate a resistor which has a value of 350 ohm. I'm just going to drag another wire and just going to connect it to pin number 4. So I can even change the color of this particular LED. Sorry, not LED, wire to black color. And I'm just going to change the color of this green wire to red color. So this is what is the connection for make this LED blink with some delay, right? So you may ask how to go about the coding for this particular operation. Actually, you don't want to worry about this coding and all. This will be done through the simple blocks. So I think you can able to see this block. While selecting this particular block, that is code block, you don't want to write any codes here as a beginner for this Arduino. If you know the logic for glowing that particular LED, you can just build using blocks. Coding is not required for this particular Tinkercad. So what we are going to do is, I'm just going to pick the output. It is going to perform some output, so I'm just going to pick it from your output. So this is the block you need to select, output block. Okay, so I'm just going to select this set pin 0 to high. So this is what I'm just going to select. So which pin you are going to set high? So I'm just connected this this LED with your pin number 4. So I'm just going to select it to pin number 4. So I'm going to make it as high. Next is I need to give some delay. So I can go for some wait operation. I'm going to wait for 1000 milliseconds. That is 1 second. And again, what I have to do is I have to turn off that particular LED. Okay. So which LED? The LED which has been connected to the pin number 4, and I'm going to make it as low. And again, I need to give a delay of 1000 milliseconds. So that is it. So this will be continuously running on a loop, and you can see how it works in this particular simulation. So I'll start the simulation here. So you can see that LED is glowing for 1000 milliseconds, and it is turned off for 1000 milliseconds. So this is what is the effort taken to make the LED blink. Right, you can also differentiate that blink with different delay values. Now we can also start the simulation, where I think you can able to differentiate the off state and your on state here. Okay. So now I think that there will be a question raised in your memory whether I can use this particular blocks for incorporating in a real-time Arduino board, in a Arduino development board. Yes, but you cannot incorporate this particular block. But this Tinkercad is offering you an excellent solution for that. If you go and select this particular block, here you'll be having block plus text. So if you select this particular block plus text, and code will be automatically generated for you. So you don't want to worry about the coding and all. What you have to do is you have to know the logic, what you are going to do. Just to build this logic using this blocks, the code will be automatically generated, and you can make use of this particular code for implementing in the real time. So this is what is the effort made for making an LED blink with a logic, right? So I think this particular Tinkercad, I think it would be very easy for you. So now let us go into the next thing for Tinkercad. So I think now I can rush up with certain applications. Because I think most of you would have know how to handle a component. So I'm just rushing up. So what I'm going to do is, in recent days, in our COVID-19 situation, this new normal situation, like when the COVID-19 was in the peak, actually it didn't come down, actually it is still in the peak. So at that time, few technologies or a few gadgets was spoken very much. I think most of you would have know about what are the gadgets which was spoken or which was bust very much during that period. That electronic gadgets which were bust very much. So can anyone give some examples for the different devices or different electronic gadgets which were very popular during the COVID-19? Just you can just tell what are the different gadgets, that's it. So if we need wherever we go, wherever the place we go, even for a shop or even for a, yes, right, that was a thermometer, that was a digital thermometer. And another major thing which was bust was oximeter, definitely. Weighting machine, okay. Right. So I think I came across 4 different electronic gadgets which were very popular on that COVID-19 situation. One was, as you told, as Mudasir sir said, like thermometer, digital thermometer, that is your forehead thermometer, that is one of the best example. Second one, oximeter, that is also a very good example. And I can see few school students were developing some kind of automatic hand sanitizer. That gadget was also was a buzzing application which was developed during that COVID-19 situation, because most of them were using that hand sanitizer very frequently. If we keep that particular hand sanitizer in a particular common public place, most of them will be handling that. So in order to avoid that, few students combined together and they form and developed gadget that we call it as an automatic hand sanitizer. When a person just approaches near that hand sanitizer, it automatically ejects that solution into our hand. So that is also a good example or good gadget which was developed during this COVID-19. And the other major thing which I was surprised to see, that is that sanitization tunnel. Actually, it is not. I think it is not hygiene, good for health, but still, it can able to remove that virus infections which is there inside in the cloths which we wear, and the virus which is there in the body. So it is actually a good initiative, and all those things. I think I have developed the simple solutions in over there in Thinkercad. I can able to show that for you. So first, let us start with the first one. That is and social distancing device. I'll log out and I'll log in with my other account. Yes, this is the one. I can even share all those circuits. It is a link. You can just click that link and you can open and access. If you create an account in this Tinkercad, you can access all my circuits which are there in my dashboard. I can even share my links over there with Ravi sir, so that you can make use of it later on, right? So this is a social distancing gadget. Actually, these things are very simple. When we incorporate it in real time, it will be looking like it was a huge invention, but it is very simple one. Already those things are existing, but still it gives a confidence that we can also make a simple electronic gadget without having a much knowledge about Arduino or much knowledge about the programming skills. I can develop a particular project just by knowing the logic what is there, right? So this social distancing gadget, which it is consisting of 3 different components. Either you can make use of this LED or you can make use of some kind of buzzer. I'll show you both. First, we need a Arduino UNO. Second, we need an ultrasonic sensor. Ultrasonic sensor is nothing but it does two different operations. One is echo and the other one is trig. In one way, it will be sending an ultrasonic wave. If there is any obstacle over there, and this ultrasonic wave will be hit over that obstacle, and it will be reflecting back, and it will be captured by your other side of your ultrasonic sensor. So the time taken for sending this wave, hitting the obstacle and coming back will be calculated, and this time will be converted back to the distance. So this is what is the working principle of your ultrasonic sensor, right? So what we are going to do is we are going to build a program over this. So this particular ultrasonic sensor will be having three different pins. One is your ground pin that needs to be connected to the ground. Secondly, we need to connect the VCC pin. VCC pin is nothing but the voltage pin that needs to be connected with the 5 volt. And the last pin is your signal pin. And the signal pin is nothing but the signal which is being received from the ultrasonic sensor that needs to be processed inside your Arduino UNO. So this is what is being done here. So the signal pin will be getting the signals from your ultrasonic sensor, and it will be giving it to your analog sensor, that is analog pin A0. This particular ultrasonic sensor doesn't have any analog to digital converter, so it is just an analog sensor. So this is what is the effort for building this particular product, right? So now let us look into the code for that. Okay, so this code is also quite a bit simpler. So what we are going to do is here. So in the input tab, you can see a particular block that we call it as read ultrasonic distance sensor. So this read ultrasonic distance sensor is nothing but this particular block will be able to track the distance, or it will automatically generate an ultrasonic sensor, and it will be turned on for a particular duration. So I'm just telling the process of work which is happening inside your ultrasonic sensor. So it will turn on that ultrasonic sensor for a while, that ultrasonic wave for a while. So it will be hit on an obstacle, and it will be getting reflected back, and it will be captured on the other knob which is there in the ultrasonic sensor. So all those things will be taken care with the help of this particular block. Okay, so the second thing is we have to introduce a variable, that is a new variable that we call it as your distance. So this is what we are just going to do. What exactly it is done is, so first we have taken a ultrasonic sensor. So in that ultrasonic sensor we have connected it to a A0 analog pin. So the trigger pin, rest of the things, it has to be kept as it is. So the echo pin and the trigger pin has to be very same. So same as the trigger pin. So how we are going to calculate the distance? It is going to calculate the distance in the centimeters. So next is, I'm just going to do some processing over there. So what I'm going to do is set distance to, I'm just going to bring this ultrasonic sensor into this particular block. Okay, so the next is, I'm just going to print this value. So whatever it is going to capture, that ultrasonic sensor is going to capture the distance. So what I'm going to do is, I'm just going to print that value. So what I'm going to print, I'm going to print the distance value. So I'm just bringing this distance to here. So this is the second operation. So what I'm going to do next is, if the distance is less than 100 centimeter, so as we are calculating the distance in centimeters, if the distance between the obstacle and the ultrasonic sensor is less than 100 centimeter, what I'm going to do, I need to glow a alarm, or I can indicate it using a LED. So if a person, if it is a social distancing gadget, we have to maintain some distance between two persons. So if the distance between the two persons is less than 100 centimeter, it needs to give an alarm. So this can be incorporated miniaturely. It can be incorporated in your ID cards and tags, and this can be carried to your office to maintain your social distancing. So what I'm going to do, we need to put a control over there. So what is that control is, I can give a if-else statement. So what is that if-else statement? I just need to give some mathematical operations over there. So what it is going to do is I'm just going to select this math operation, and I'm just selecting this block. So what I'm going to measure, I'm just going to measure the distance value. So I'm just posting the distance over here. And then what is the distance to be maintained? It has to be 100 centimeter. So if it is 100 centimeter, what it has to do? If it is less than 100 centimeter, what it has to do? The output is you have to set a particular digital pin to high. If it is distance is less than 100 centimeter, your LED has to glow. So LED is connected to which pin? It is connected to pin number 7. So we need to select the pin number 7. So it will be made high. So if it is not less than 100 centimeter, there will be another logic. So we need to put this, and we need to choose the pin number 7 where the LED is being connected, and we need to set it to low. So this is what is the construction of program which has to be done. So okay, let us remove this. Just keep this alone. So this is our coding part. First, this distance variable is incorporated. Then ultrasonic for measuring the distance alone, there is a separate module over there. So then I'm going to read this distance value and going to print it on the serial monitor. Then I'm going to introduce a if-else statement. If the distance is less than 100 centimeter, I need to glow a LED which has been connected with the pin number 7. If it is not less than 100 centimeter, then I have to turn off the LED. So this is what the logic behind. So I'm just I'll try to run this particular module. So start simulation. I can remove that coding part. So if we click this particular ping sensor, you will be getting some area, that is area which is being monitored by the ultrasonic sensor. So now this, consider this blue color dot as a obstacle. I'm just moving that obstacle. So it is beyond 100 centimeter. So here you can see the distance in inches as well as in the centimeter in your above the ultrasonic sensor. So if you are coming towards the ultrasonic sensor, because this particular ultrasonic sensor is it's been with you. Actually, if you have this particular gadget, you will be having with you. It will be there with you. So if some person is coming beyond that threshold distance, that is given as 100 centimeter, right? So if it is coming beyond 100 centimeter, your LED automatically turns on. So you can either incorporate this LED, or you can make use of the buzzer which is there available here. This is a piezo buzzer, and the noise created by this particular buzzer will be pathetic. So only I just incorporated this LED. So if I okay, I think that is what I told, like the noise created by this particular piece of buzzer will be very pathetic. So when I come closer to this ultrasonic sensor, so what happens? This automatically this LED will be glowing. At the same time, your piezo buzzer is also giving some buzzer sound. So this is one of the social distancing product which can be developed, and you can also ask whether this can be implemented in the real time. Yes, definitely it can be implemented with the program which has been created for this block. So this block, creation of this particular block is going to take a very little amount of time, and for learning the logic and how to pick a component from that block is not going to take much of time. But if you are going to learn this one, definitely it will take some time for learning this program. So instead of going directly into the program, we can able to learn this particular blocks very quickly, so that we can incorporate in many projects. So as your Tinkercad is offering this solution, that is blocks can be converted into program. So this program can be copied and just paste it over your Arduino software, and it can be downloaded into your real-time Arduino also. So this is what we call it as your social distancing gadget. Next, we'll see about I think it is getting late, so I'll jump into one of the cloud application, because I need to show any one application at least with IoT. Ravi sir?
Sir.
Ravi sir, is it possible like I can take 10 more minutes?
Okay, sir. Okay, sir. Okay.
Is there any issues?
No, sir. No, sir. Per sharply, you 10 minutes you wind up, sir. Okay.
Yes, yes, thank you.
Thanks.
So, as I told, similar to this Tinkercad, you don't want to worry about the coding and all. I'm just going to introduce a new online that is cloud application which can be incorporated for IoT applications. So that application, we call it as a Remote XY. So I think my screen is visible, right?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Thank you. So first, what we are going to do is I'm just going to enter into this Remote XY cloud. So this is the home page for that. So what I'm going to do is I'm just going to start now. There will be a green color button over there, and just click start now. And I'll go for a new project because yeah, this is a new project, right? This is the environment we are going to develop a IoT application for your mobile. This is an application which is going to be developed for controlling a particular LED. We can just take an LED example itself. I'm just going to control a LED using this particular application which I am going to develop, right? So if I take a simple LED, what I'm going to do is I can able to turn on and turn off. That is the control that can be implemented for an LED. So I'm just going to do it over the internet by incorporating this application into my mobile. I'm just dragging and clicking that control elements. We have different control elements over here: button, switches, select, slider bar, joystick, and RGB. So this particular tool, that is your Remote XY tool, is an excellent tool for performing applications or developing applications for robotic applications, IoT based robotic applications. So I'm just using this for creating a simple logic to turn on and turn off a LED. Okay, that is what I'm just going to show you. And so I'm just dragging a switch button from there to here. So now the next step, what I'm going to do is I just need to configure the device. So what device I'm going to use, so that device I need to configure. So what sort of application I'm going to use, whether I'm going to use a communication protocol or Bluetooth or Wi-Fi or internet or cloud, anything. So I need to choose that first. So by clicking the configuration button in the right hand side, I can choose different aspects. So first, let us click on the Bluetooth. So a new window will be opened. So in the connections, I'm not going to use Bluetooth. I'm just going to use a cloud server. Okay, I'm just going to use a cloud server. Secondly, I'm just going to choose a device. So that device, I'm just choosing it. I'm just going to choose this particular board, that is VMOS D1 board is the board I'm going to use. And then lastly, what module you are going to use. So VMOS module will be having an onboard chip, Wi-Fi on chip. So I'm just going to make utilize of that particular thing. And what IDE I'm going to use, integrated development environment, I'm just going to use Arduino IDE. I'm just going to select that particular Arduino IDE. So I'm just configured everything. I'm just going to use a cloud server. I'm going to use a VMOS board, and that will have an onboard Wi-Fi chip, and I'm going to use a Arduino IDE. So you need to apply all those things. Okay. So next, what you have to do is module interface. So in this module interface, what you have to do is I have to give my Wi-Fi access points details. Okay, here I need to type my Wi-Fi access point name, whatever the access point which is there. I can give, and your password we can able to give. So you can able to give some password in some kind of password. And token, the next one is token that we need to generate. Actually, if you click this particular my tokens, that is nothing but the authentication token which is going to connect your device and your cloud server. So we need to generate a new token. So if you click my token, it will take to a token creation window. So in this create new token, if you click that, it will be asking for some certain details, what cloud you are what board you are going to use, and what cloud server you are going to use. So I'm just going to select cloud.remotexploit.com and then create. Just that is what we are going to do. So this is the token which has been given for your application. So this token will be it's making your controller as well as your cloud server to communicate with each other. So this token is actually very important. So let us go back and we can select that particular token. We have given the token name as G, so that G token will be selected. Rest of the things it will be as it is. So then what you have to do is you have to choose this particular switch button. If you choose that switch button, so you have to select in which particular pin you have connected the LED. So I'm connecting this particular LED with the D5 pin. So D5 pin is nothing but it is a pin which is there available in your VMOS board. So this is what you are going to do. We have done almost around 90%. We have completed this project. That is what is the effort I'm going to give. First, I'm going to create a new project. I'm just going to drag a button or a switch over here. I'm just going to configure it. I'm going to configure it as cloud, VMOS D1, Wi-Fi on chip, Arduino IDE. Then I'm going to give my Wi-Fi SSID and password. I'm going to create a cloud server token. So this token will be helpful in connecting your onboard, your controller as well as your this thing, that is your cloud server. So this is what you are going to do. And then to which pin you have connected the LED? I have connected the LED with pin number D5. So this is what is being the effort taken. Now what I'm going to do, I'm just going to generate the code for this project. So you don't want to know about the coding and all. You can generate automatically. This code will be generated automatically. Just click on, you'll be having a block here as get source code. So just click on this particular get source code, and this code for this particular project will be automatically generated. What you have to do is you have to follow these steps. So first thing what you have to do is I have to download the source code. Secondly, I need to install the remote XY library into my Arduino IDE. Third, I need to compile. I need to install this remote XY in your mobile phone, and then connect it to your connect this ESP module with your mobile application. So this is what I'm just going to do. So for that, what I'm going to do is I'm just going to create a new project. So what I'm going to do, first thing, I just need to copy this code. So copy this entire code. So this was a code generated for my application for controlling an LED. I'm just going to copy this, and I'll just paste it over the new sketch which I've created in the Arduino IDE. So I've pasted it. This is the effort for writing a project for controlling an application or controlling a electronic gadget. So this is what I'm just I'm doing for performing that much big task. It is considered as a big task, that is controlling a bulb through Wi-Fi, but the effort taken for that is a very little amount of effort. So I'm just selecting the tools over here. In this tools, first I need to select what board I'm going to use. So board here I can choose ESP8266 boards. So over there I have to select Vmos D1. So I can find Vmos D1 R1 here. Yes, this is the board I'm using it. And if whenever I'm connecting my Vmos board with my laptop, yeah, whenever I connect my Vmos board with my laptop, I can see this port showing as COM3. So to whichever USB port you connect, that it will be showing with some kind of communication port. So now it is showing as COM3. So this is what we need to select. So the next thing is, as this particular Remote XY software is telling, or this online application is telling, so you have to install your Remote XY library. So what I have to do is I have to install the library. So for that, what you have to do is you have to select the sketch, include library, and if you have a good connectivity, internet connectivity, you can go for manage libraries. So if you click on that manage library, so this window will be opened, and over here, so there will be a space for searching for a particular library. If you type Remote XY, so the corresponding library will be there available in your Arduino itself when we are connected with the internet. So you have to select a particular version and you have to install. But it is there already installed in my laptop, so I'm not installing here. If you just click this install, that is more than enough. You can your library will be installed. If you are not available with your internet at that time, what you can do is you can just download this Remote XY library. Just click on this particular library, you will be taken to some other place, and the latest version of your library can be downloaded by clicking just download button. So you'll be getting this Remote XY as a zip file. So now what you have to do is you have to again go into tools, you have to go into sketch, include library, and you have to add zip libraries. So zip libraries, if you select that, you have to navigate and you have to select the place where exactly it is downloaded. So if I go there, Remote XY will be there. If I click open, it will be automatically installed. So this is what this is how you need to incorporate the library file for your Remote XY. So without library file, it will not be working properly. For each and every header you are going to use, you have to include your library. Even for your Wi-Fi, your Arduino is an open board. You can incorporate any kind of sensor or any kind of display device or any kind of connectivity device can be incorporated. So for incorporating anything, you need to include that library function, library also to the program or to the IDE. So if you are going to make use of this Wi-Fi, you have to again you have to go and search for your ESP8266 Wi-Fi library in your GitHub. So GitHub will be giving some library zip file. You can directly add it to it, or otherwise, if you have a good connectivity, as I told, you can go to the manage library and you can search for this ESP8266 Wi-Fi module and you can directly install it online. So this is what is going to happen. So once everything is set, what I'm going to do is I'm just clicking this particular button. So this button is the compilation button. So I'm just clicking it. It will be asking for saving this project. I'm not going to save this project. Just compilation is okay for me. And see here, you can able to see that. So little more things are copied, so we can remove that. So here you can see that your Wi-Fi SSID and password has been already incorporated from your that app generation online dashboard itself. From that dashboard itself, you are getting all sorts of details from that application itself. Whatever it was given as an input, and it will be incorporated in your program also. So this is the thing for compiling this particular program, and I'll just click this particular button. If there is no error in this program, it will be showing done compiling. If there is done compiling coming, I can just press this arrow button. So this arrow button will be showing to download this particular code into the board which you are connected with your system. So here in this case, I've connected with this. I've connected with vMOS board, right? So I'll show you the board right now. Just a minute, kindly give some time. Yeah, so this is the board actually. This is the vMOS board. So here you can, I think, is it visible? Is the board visible?
Yes, sir. Yes, sir. Yes, sir. Visible, sir.
Yeah, this is the board, and here you can see the onboard Wi-Fi module which is there connected on the development board itself, and I've connected, as I told, I've connected this LED. So this is the LED. This is the LED, and it has been connected to the D5 pin, and the other leg will be connected to the ground. So I'm just connecting this through a USB cable to my system. So this is what is the connection. If you are going to implement in the real time, that is through a power supply, that is 12-volt power supply, you should not directly use this LED because as I'm using this, because it is connected with my laptop. So as it is connected with my laptop, only 5 volt will be entering through this, so that it won't damage my LED that much. So I'm just using it without any resistor. If you are going to implement in the real time, you can go for resistors and all. So the next thing what you have to do is we have to install Remote XY in your mobile phone. So this is the application, Remote XY application. So there will be a plus button on the top of your application. You have to click over there, and you have to select what communication protocol you followed. That here I'm going to select your cloud server here. So here the authentication token which you used in your program, that has to be incorporated here. You have to manually type, or just you can just copy it and you can paste it. So now when I incorporate that, I have created a dashboard now, and this dashboard is directly connecting with the particular application which I developed. So I'm just clicking over here. So now it is getting connected with that cloud, and I'm getting the turn on and turn off button. Right. So now I'll turn on simultaneously. I can show you both. So I think the board is visible, I believe, and at the same time my screen share is also visible. So I'm just rocking on that switch. So I think you can able to see that LED is glowing now, and I'm just turning off, and your LED is turned off. That is the effort, that much only. Internet of Things is not a rocket science. You can be able to study that very quickly if you know the logic behind those things. So I've created a switch, and that switch was being incorporated with this VMOS board, and automatically this particular remote XY tool is generating that program for this VMOS board. I'm just starting it turning on it and turning off it. So I'm just connecting a simple application that is a LED here, but you can able to connect a relay with this particular pin, whatever I've configured. You can connect your fan, or you can connect your electronic appliances which are there in your house, or you can able to connect any kind of electronic gadget and which can be controlled over this mobile application, that is your remote XY. So this particular remote XY, I think you will be able to easily understand that program is not required, only the logic is required. So this is a simple application with the help of your VMOS and IoT. Through IoT, I'm just controlling the LED which has been connected.
Thank you, Professor.